In a revelation that could alter the course of human history, NASA has recently disclosed an extraordinary breakthrough, one that has the potential to transform how humanity perceives its place in the cosmos. For the first time, astronomers have detected what appear to be structured signals coming from Proxima b, the closest known exoplanet to Earth. This planet orbits Proxima Centauri, located slightly more than 4 light-years away, within the so-called habitable zone where conditions might support life. This astonishing announcement has set off a wave of global speculation and enthusiasm. It revives an age-old question: is humanity truly alone in the vastness of space? Or have we finally found proof that life, perhaps intelligent life, exists beyond Earth? The path to this discovery was anything but accidental. NASA's advanced observational instruments, particularly its powerful space telescopes, have been studying stars and exoplanets for years, including Proxima b. Because of its close proximity and Earth-like attributes, Proxima b has long been considered a promising candidate in the search for alien life. Recent findings suggest this exoplanet may not just be capable of sustaining life, it might already be doing so. What distinguishes this signal is its apparent structure and order, something that rules out known cosmic phenomena or random noise. It doesn't resemble pulsar emissions, solar flares, or man-made interference. Its unique pattern hints at a potential intelligent source, leading researchers to intensify their analysis. Scientists are now racing to decode the signal, analyzing its frequency, timing, and potential embedded information. The origin of the signal, tentatively called Breakthrough Listen Candidate 1, BLC-1, was first identified in April 2019 by the Breakthrough Listen Initiative, a privately funded $100 million program aimed at scanning the skies for signs of extraterrestrial intelligence. The Parkes Radio Telescope in Australia picked up the signal while observing the region surrounding Proxima Centauri. Out of millions of radio signals collected, this one stood out as remarkably distinct and technically refined. To qualify as a candidate for extraterrestrial communication, a signal must meet strict criteria. It should lie within a narrow frequency band and show Doppler shift properties that correspond with the motion of an orbiting planet relative to Earth. After meticulously examining over 4 million signals, researchers confirmed that this specific transmission aligned with Proxima b and lasted over 30 hours, only appearing when the telescope was pointed at that star system. Proxima b itself was discovered in 2016 using the radial velocity method, which detects wobbles in a star's movement caused by the gravitational tug of orbiting planets. This planet is slightly larger and more massive than Earth, suggesting it's rocky rather than gaseous. It lies just 0.05 astronomical units from its star, much closer than Mercury is to our Sun, yet its host star is dim enough that Proxima b still lies within the habitable zone. It receives about 60% of the stellar energy Earth does, possibly allowing for liquid water on its surface, a key ingredient for life. What makes Proxima b even more intriguing is how similar it is to Earth in several respects, despite being bathed in a different kind of starlight from a red dwarf. The planet's size, mass, and likely rocky composition place it among a small group of Earth-like exoplanets that offer hope for habitability. Since the planet's discovery, scientists have been exploring its potential to support life. Now, with the emergence of a possible artificial signal from its direction, those investigations have taken on a whole new dimension. If the signal is proven to be a form of interstellar communication, it could mean that a civilization on Proxima b is attempting to reach out. The implications of this are monumental. First, it would lend enormous weight to the scientific notion that life can thrive in environments beyond Earth. Second, and perhaps more provocatively, it introduces the concept that intelligent life has not only developed elsewhere, but may also possess the means and desire to communicate across the stars. This revelation has not remained confined to laboratories and observatories. It has spilled into public discourse, stirring conversations in academic halls, government forums, media outlets, and homes across the world. Many are grappling with the possibilities. Could the signal be a deliberate attempt to contact us? Is it a greeting or a warning, or something we cannot yet comprehend? Speculation has erupted around the nature of the civilization that could have produced the signal. Are these simple organisms that somehow evolved communication? Or are we potentially dealing with an advanced society far beyond our technological grasp? Could they have mastered concepts like faster-than-light travel or quantum messaging? Are they peaceful, or do they harbor unknown intentions? NASA, fully cognizant of the potential magnitude and implications of this extraordinary discovery, has chosen to approach the situation with measured, cautious optimism. While the prospect of receiving a structured signal from the direction of Proxima b is undeniably exciting, and perhaps even historic, scientists and mission specialists are resisting the urge to leap to conclusions. After decades of false alarms, data misinterpretations, and naturally occurring cosmic phenomena mimicking artificial signals, the space agency is taking great care to ensure that all variables are thoroughly examined and all alternative explanations are systematically ruled out before declaring anything conclusive. The possibility that the signal could stem from an intelligent extraterrestrial source is being considered, but only alongside a multitude of other, more mundane possibilities. It is standard scientific procedure to first eliminate any and all potential sources of error before accepting such a groundbreaking hypothesis. This includes confirming that the signal is not a byproduct of human-made interference, such as satellite transmissions, Earth-based radio equipment, or reflections of signals bouncing off space debris, or a naturally occurring but poorly understood astrophysical event. To that end, NASA has mobilized a broad and interdisciplinary team of experts to conduct rigorous reviews of the data. Astrophysicists, radio astronomers, signal analysts, and engineers are meticulously combing through the observations, using both automated algorithms and manual inspection to check for anomalies, inconsistencies, or signal artifacts that could cast doubt on the initial interpretation. The data is being cross-referenced with other observations from various space and ground-based observatories around the world to determine if the signal can be independently verified. If it is, that strengthens the case for its authenticity. If not, the anomaly might be unique to the original equipment or time of observation, which would necessitate further investigation. Moreover, NASA's approach is guided by its long-standing commitment to scientific integrity and transparency. Rather than rushing to make bold declarations or dramatic claims, the agency is adhering to a methodical process of evidence collection, peer review, and internal validation. Preliminary findings are being shared with international collaborators and independent research institutions to invite outside scrutiny and gain a broader perspective. Until the source and nature of the signal are confirmed beyond reasonable doubt, the scientific community is categorizing it not as proof of extraterrestrial life, but rather as an exceptional anomaly, an unusual, structured transmission that deserves thorough and careful scrutiny. Only after all known natural and artificial explanations have been eliminated, and only if the signal exhibits consistent behavior that suggests deliberate design, will the hypothesis of an intelligent origin gain serious traction. In the meantime, NASA's deliberate and meticulous approach serves as a model for how to handle potentially world-changing discoveries, with humility, rigor, and a deep respect for the scientific process. The truth, whatever it may be, is worth waiting for. The discovery of the signal is also reviving ethical discussions. How should humanity proceed if this turns out to be authentic contact from another intelligent race? Should we respond, or simply listen? And who gets to decide? Scientists, politicians, philosophers, or perhaps a coalition representing all of Earth? At the core of this is a deeper, more personal reflection on what it means to be human. For millennia, we have looked up at the stars, wondering whether someone, somewhere, was looking back. If these signals prove authentic, that age-old curiosity will finally be met with confirmation. The larger scientific community, including organizations beyond NASA, is collaborating on decoding the message. This includes contributions from experts in linguistics, computer science, mathematics, and cryptography, all striving to crack the code that might hold answers to some of humanity's greatest questions. Meanwhile, cutting-edge tools like the James Webb Space Telescope, JWST, are further revolutionizing the field. JWST's incredible power, nearly 100 times that of the Hubble telescope, allows astronomers to study exoplanets with unprecedented detail. It can detect biosignatures in planetary atmospheres, map surface conditions, and observe the formation of stars and planetary systems using its infrared vision. Already, JWST has identified multiple promising exoplanets, including Kepler 1649c, which shares remarkable similarities with Earth in terms of size, temperature, and orbital patterns. These advancements reinforce the notion that Earth-like planets, and possibly Earth-like life, may not be as rare as once thought. The telescope's ability to peer through dust clouds and identify molecular signatures such as water, methane, and carbon-based compounds provides scientists with critical clues about the potential for life on distant worlds. By studying planets in various stages of development, JWST is helping to fill the gaps in our understanding of how solar systems and life emerge and evolve. Proxima b, given its close proximity, serves as an ideal subject for such scrutiny. The more we learn about it, the more questions arise, not just about the planet itself, but about the broader cosmic ecosystem in which it exists. Should this signal be verified as intelligent in origin, it would not only revolutionize our scientific paradigms, but also provoke sweeping cultural, philosophical, and spiritual shifts. Humanity has always imagined itself as occupying a central place in the universe. This discovery could fundamentally upend that assumption. In scientific terms, a confirmed extraterrestrial message would demand a rethinking of major theories, especially those concerning the uniqueness of life and intelligence. The long-debated rare Earth hypothesis would need to be re-evaluated, potentially replaced by a more optimistic model of a universe teeming with life. Philosophically, we would be called to reassess our understanding of intelligence, consciousness, and existence. Are we one of many sentient species scattered across the stars? What moral responsibilities might we share with other intelligent beings? Could our definitions of progress and civilization stand up to interstellar comparison? Culturally, the effect would be equally profound. Art, literature, cinema, and even music would be transformed as humanity digests this cosmic revelation. The ways we interpret creativity, express emotion, and seek meaning could shift in light of knowing we are not alone. Religious belief systems, many of which place humans at the center of divine creation, would also face significant challenges and opportunities. Some may struggle to reconcile this new reality with long-held doctrines, while others might embrace the discovery as an expansion of divine creation beyond Earth. Most significantly, this discovery could usher in an entirely new phase of space exploration, one centered not just on identifying planets, but on understanding the life forms and civilizations they might host. Instead of merely searching for Goldilocks, planets with the right temperature, we would embark on missions designed to make contact, foster communication, and learn from other intelligent species. The challenge of interpreting the message itself is formidable. If it contains data, language, or scientific knowledge, we must develop ways to understand a system of communication utterly foreign to us. This will require global cooperation across fields, cryptographers, linguists, mathematicians, and astronomers working together to unlock its secrets. Such collaboration might also strengthen bonds on Earth. A shared mission to decode and respond to an extraterrestrial message could foster unprecedented international unity, helping us focus on common goals rather than divisions. In the grand arc of history, this could represent a defining moment, one in which humanity transitions from a species confined to one planet, imagining the possibilities of life elsewhere, to a civilization actively participating in a broader galactic community. Whether the signal from Proxima b proves to be definitive contact or simply an extraordinary anomaly, it has already achieved something remarkable. It has reminded us of our shared curiosity, our collective yearning to understand the universe, and our unshakable belief that we are part of something far greater than ourselves. And should it indeed mark the beginning of interstellar dialogue, it will not only change our understanding of the universe, it will redefine what it means to be human.